This is the system analysis dashboard, which is the local interface that allows us to see all the devices connected to the mini container are their current conditions. In this case, we can see the three mini containers that we saw before, where 00 and 01 are connected directly to the CDU, and 02 is the one attached to the PCU. All the data from this mini container is being communicated via the CAN bus from each of the devices to the CCU, which is processing, analyzing, and storing the data. We see that for each mini container we have 4 temperature probes, which determine tells the CDU the internal temperature of the mini container by looking at the average temperature inside. We also have 2 humidity sensors, one inside and outside of each mini container. Also an accelerometer that tells us the orientation of the mini container and can allow us to assess some shocks to the mini containers. In addition, we can also determine the state of the doors, where they are either closed or open, to determine that to keep track of the integrity of the products. With respect to the manifold, we also see the status of the return and cold ducts, which valves are open. That means which mini container is being cooled. Also the status of the purge and recirculation valves and the temperature in the cold and return ducts. In addition, we have the humidity of the ducts, and all these parameters allow us to assess the performance of the refrigeration system. Here we have the target temperatures for each mini container, and all this data is being collected in real time in the local interface at the CDU, and it's being streamed to the cloud platform. Now, with respect to the cloud platform, this is a web platform based on internet that we can use to monitor the internal conditions of each mini container. In this case, we can see all the mini containers being attached to the CDU, and we can look at the traceability records for each of these mini containers. For example, here we have mini container 01, and we can see the temperature profile over the last couple hours. This not only tells us the internal temperatures, that if it is within the expected range, but also does an assessment of temperature excursions, meaning that the temperature went either above or below the required range. Tell us for how long was that excursion and what was the mean kinetic temperature during that period of time. In addition, we observe the records of the accelerometer readings, and this can allow us to identify if there was a shock or something hit the mini container. In addition, we can see the position of the mini containers with their temperature, the inside and outside humidity, and the battery voltage for the internal memory of the mini container. The web platform also allows us to set and change the temperatures remotely. This means if for any reason the user wants to modify the control limit for its cargo, that can be done using the platform. It's worth to mention that in case the mini container gets disconnected, either it loses connection or power, the internal battery will allow the mini container to automatically go into a data caching mode that will keep and store all the temperature and internal conditions data for a certain time until it gets reconnected to the CDU and internet, and all that data will be sent up to the cloud for full traceability. The idea of this is it allows not only remote monitoring and control, but also to have full traceability of what happened with each mini container, how was the temperature profiles, the internal conditions, the status of the doors, etc. This also allows the generation of alerts. Each of these temperature excursions can be translated to an alert to the user to tell that something went different than expected.